Now for my sign chart, once again, I'm only going to write down interesting x values, but I'm only going to write down the interesting x values for the canceled version of my problem. So once again, when those x minus 2's were canceled, we ended up getting 2x plus 5 divided by x plus 3. So I'm only interested in the interesting values that came from the new and improved f of x. So one of the interesting x values that came from that new and improved f was the value of x equals negative 5 halves for our x-intercept. So I'm going to come over here and put negative 5 halves on my number line. Now the other interesting thing that we found was an x value of negative 3 for the vertical asymptote. So I'm going to put negative 3 on my sign chart as well. However, I know that I'm going to put some information between each one of my tick marks, so I'm going to go ahead and expand my sign chart just a bit, just to make sure that there's enough space between these tick marks that I can write information. So once again, be careful though that the negative 3 is to the left of the negative 5 halves. Now if it's helpful, you can go ahead and write down the fact that negative 5 halves is equivalent to negative 2.5 in decimal format. So now that we have all the interesting tick marks for our new and improved f of x, I want to find what's happening in terms of the sign in each one of these regions. So let's choose an x value that lives to the left of negative 3. Negative 4 lives there. Well, now that we know that we have that negative 4, let's see what happens then when we plug a negative 4 into this function. So we're going to have 2 times negative 4, that's a negative 8, plus 5. That means I'm going to have a negative numerator. And then negative 4 plus 3, that's going to be a negative denominator. A negative divided by a negative is a positive. So that tells me then to the left of negative 3, we have to then have a positive function, which means that our graph is going to be above the x-axis. Now let's go ahead and, on this problem, just take that information directly to our graph. So let's see what we see then. So there are in fact 2 different places that we could live if we have y values that are positive. We could live here, or we could live here. In both of those locations, we are doing what the sign chart told us, that we have to be above the x-axis. However, based on some of the other information we know, one of these works and one of those doesn't. So if we started below our horizontal asymptote, the only place that we could do is go down like this. And if we go down, once again, we would have another x-intercept. We don't have an x-intercept to the left of negative 3. So that means that we're actually not going to be looking at a graph that swoops down forever near that x equals negative 3. We've got to swoop up forever. So let's go ahead and draw something here that goes up forever near that x equals negative 3 vertical asymptote and approaches the horizontal asymptote on the left-hand side. Well, now let's go between negative 3 and negative 5 halves, or equivalently negative 2.5. An x value that would live there, unfortunately, we're going to have to go decimal, and it's going to be something like negative 2.7. If we plug in a negative 2.7, our numerator is going to be 2 times negative 2.7. Then we're going to add 5 to that. What's going to happen is we're going to have a negative numerator. And then in the denominator, negative 2.7 plus 3, that's going to be a positive number. A negative divided by a positive is going to be a negative. So that means then, between negative 3 and negative 2.5, our graph has to be below the x-axis. So let's go ahead and put that information in here. We have to go through this x-intercept, and between negative 3 and negative 2.5, we have to be below the x-axis. The only way that works then is if we approach that vertical asymptote and go down forever there. Well, let's keep going. To the right of negative 2.5. Once again, if I have something that I can steal from earlier in the problem, I'm going to do it. So x equals 0 lives to the right of negative 2.5, and we already calculated that the y-intercept was positive there. So we know then to the right of negative 5 halves, we have to have a graph that's above the x-axis. So let's go ahead and finish off our graph then. So here we're going to be above the x-axis, but we also have to go through that y-intercept. And we also have to approach that horizontal asymptote of y equals 2 as we move to the right. So the only way that all happens is if our graph looks something like that. Now, as you look at this graph, it's tempting to say that we are done with this problem. However, there is one last piece that we need to talk about. It goes back to the idea of domain. So remember that the domain was calculated before we did the cancellation. So one of the x values that we couldn't use on this problem was an x value of 2. But if you look at our graph, here's the x value of 2, and here's a point on that graph associated with that x value of 2. That cannot happen because 2 is not in our domain. So what we have to do then is figure out how to remove 2 from our domain. Another way of saying that is we need to figure out a way to remove 2 from our graph. What that means is we're going to have to come in and just erase that point off of the graph. But if you simply erase the point, sometimes it doesn't necessarily demonstrate the idea that that point went away. So you want to come in and put an open circle right there. Now, in order to describe what's happening there, this looks an awful lot like if this was a road. It looks like a pothole. So that's actually how this guy gets his name. This is a hole. So whenever you have something like this x value of 2 that's associated with the fact that it was canceled, you always have to ask yourself, where would the hole be for this particular problem? And on this graph, the hole is hanging out there at an x value of 2. It can't be part of the graph because it's not part of the domain.